Okay, today we're going to be doing the washer method. So to figure out the area of a washer, we're first going to look at this area over here. So if I wanted to find the area of the purple shaded region, that means I don't want the area of this box right here. So I'm going to want to subtract that out. I would do the area of the purple rectangle, which would be 5 times 20. Then I would do minus, and I would subtract the area of that square. So I would subtract 3 times 3. That would give me 100 minus 9, which is 91. So the area of the purple shaded region is going to be 91. We're going to use the same idea to do the area of a washer. So for the area of the washer, we're going to start by looking at the washer right here, and we want the area of the yellow shaded region. So we're going to do the area of this big circle, and then we're going to have to subtract the area of the small circle. So we're just getting pi r squared minus pi r squared. The big R would be the radius of the big circle, and the little r would be the radius of that small circle. And that's it. So let's try an actual example. Okay, for example number 1, we're going to rotate our shaded region around y equals 10. The hardest part is going to be to identify the big R and the little r. So our little r is just going to be top minus bottom. So it's just going to be 10 minus, and then the line is going to be 2x plus 3. And that's going to be our little r. For the big R, we're going to do it in red. Still going to be the top minus the bottom, so it's still going to be 10 minus, but the bottom is going to be the curve, so the bottom is going to be x squared. And that's pretty much it. We're trying to rotate that shaded region around the line y equals 10. If you look at one of these little dotted rectangles here, we rotate that around y equals 10. It's going to create some washers. It's kind of like a donut. So instead of a disc, we have washers. Now we are going to fill in the washers from x equals -1 all the way to x equals 3. So we want our integral to go from -1 to 3. It's going to be pi big R squared minus pi little r squared. Let's go ahead and plug in those r's. Okay, I want you to notice that this is pi and then the big R squared minus pi and then the little r squared. Now you could distribute this negative on both pieces if you want. That would give you 7 minus 2x. Let's go ahead and do that. All right, that's pretty much it. Let's go ahead and plug it in our graphing calculator. Okay, I want you to notice that we do have the integral of pi r squared minus pi r squared. My r's are just parentheses right now. So now I'm going to go in and put in the big R first. That's going to be 10 minus x squared. Then we'll put in the little radius, which is 7 minus 2x. That's pretty much it. We'll push enter. It's giving me 704 divided by 5 pi. And that's it. That's our final answer. Let's take a look at the next question. Okay, for example number 2, we're going to go ahead and rotate our shaded region around the line x equals 6. So that's going to be our little r, and that's going to be our big R. Let's make our big R red. All right, so our little r is going to be 6 minus, and then the curve. The big R is going to be 6 minus, and then the line. We are going from y equals 2 to y equals 9. All right, so our integral is going from 2 to 9, and it's pi r squared minus pi r squared. We always put the big R first, and then minus, and then we do the little r second. All right, let's plug in both of our r's. All right, there we go. Let's go ahead and plug it in our graphing calculator. All right, the first thing I'm going to do is I'm going to type my functions in on y1. Otherwise, it'll just be way too messy when you type it in the graphing calculator. My big radius is going to be y1, and then my little radius is going to be y2. Then I'm going to go to the home screen. From the home screen, I have the integral of pi r squared minus pi r squared, and my y goes from 2 to 9. But I haven't put the radius yet for each of them. I just have parentheses here. My big radius was y1, so I'm going to put y1 of x for the big radius. My little radius was y2, so I'm just putting y2 for the little radius. Then we'll push enter. When I push enter, I get a really weird fraction, so I'm just putting green enter, and I'm going with the decimal approximation. Okay, we'll put a box around the final answer. I'm just going to truncate it. I'm going to go with 115.378. All right, let's go take a look at the next example. All right, for our third example, we're going to rotate the shaded region around the line y equals 8. So it looks like the big R is going to be the line minus the curve. And it looks like the little r is going to be the line minus the line. Let's go ahead and write that down. Okay, so it's basically top minus bottom. The top is 8. And then for the big R, the bottom is the curve. So the bottom would be e to the x plus 1. For the little r, the top is 8, and the bottom is the line, so the bottom is going to be x plus 4. Okay, it kind of looks like it goes from -3 to about 1.5, but we're not really sure. We can't guess. So we're going to need to solve where this line is equal to this curve. And we'll do that, and that'll be our a, and that'll be our b. So our integral is going to go from a to b. We still need to find those values. And it's going to be pi r squared minus pi r squared. We know what the big R is. We know what the little r is, so those will be easy to plug in. The only thing we don't know is we don't know the a and the b. Those are x values. So we need to solve that with the graphing calculator. And of course, we'll solve it for x. Yeah, I plugged in the big R. I plugged in the little r. I even simplified it a little bit because it was easy. And I won't need to plug those into y1 or y2 because they're so simple. They're so basic. There's really no need to plug those into the y1 and y2. I do, however, still need to solve for the a and the b value. So I'm going to need to solve this equation right here. We'll go ahead and push diamond and then enter. And there we go. There's our a and b values. Let's go ahead and store them as a and b. The negative 2.947 is going to be our a. The 1.505 is going to be our b. And now we can do the integral from a to b. We have pi r squared minus pi r squared. Our big R is going to be 7 minus e to the x. And our little r is going to be 4 minus x. All right, let's go ahead and truncate our answer. We're going to put 186.573. I do want to point out it's very important that you say let a equal this and b equal this. You have to write that on your paper if you're doing a free response question. And then once you do that, it's okay just to do the integral from a to b. Now we're going to use our answer from number 3 to help us answer number 4. We know that y is equal to x plus 4. And we just found our x values. So we found our a and we found our b. So it'll be really easy to find the y values. We just add 4 to all the x values, and that will give us our y values. Let me go ahead and do that. Okay, again, a was an x value. So if we add 4 to it, we'll get the y value. Same thing with b. B was an x value. So if I add 4 to it, I'll get the y value. And I'm getting that from this equation here. Both of those points go through that line. So for every x value on that line, if you add 4 to it, you'll get the y value. And that's the trick that we're going to use for number 4. Number 4, we really need to find those y values, but we don't need to do a bunch of work. Our y values are going to be a plus 4 and then b plus 4. We've already said what the a and the b are. So here's number 4. Again, it's called the challenge problem. This will be our little r. This will be our big R. Let's make the big R red. And because we're going around the line x equals 6, it's kind of like going around the y-axis. So everything's going to be y. So our integral is going to be from c to d. And those are the y values of these 2 points. We just figured out those y values. All we had to do was add 4 to the x values, and it gave us the y value. All right, there's our integral. It's going to be pi r squared minus pi r squared. All right, let's go ahead and plug in those r's. All right, there we go. We plugged in the big R, we plugged in the little r, and we need to write what c and d are equal to. Remember, to get c, that's like the y value. All we had to do was take the x value and add 4. Same thing for d, we just had to take the x value and add 4. All right, we plug this in our graphing calculator, and we're getting 230.031. We're going to go ahead and truncate it, so I'm going to put a box around it, and that's our final answer. Now, this question is considered a challenge question. This was a tough one. And what made it tough was finding C and D using the A and the B. So you had to use the A and B in order to find the C and the D. That was a little bit tricky. Okay, so now we're going to quickly go through a bunch of examples. We're not actually going to type it in a calculator. We're just going to write the integral, and we're going to write the bounds. And if we have to solve for the A and the B, I'm going to show you which equation you would type in your graphing calculator so that you could solve for the A and the B. So for this first example, the big radius is going to be the red one, and it's going to be the top minus the bottom, so it's the curve, and then minus, and then the bottom is just y equals 2. For the little radius, we're doing the top minus the bottom, but the top is 2, minus, and then the bottom is just 1. It's just y equals 1. So the little radius is always going to be 1. Now our integral does go from a to b. Those are x values. But we got to solve for the a and the b. And we'll do it by setting the curve equal to the line y equals 2. So we have to solve this equation here to find our a and our b. And that's pretty much it. Once you plug in the big radius and you plug in the little radius, you'll basically be done. That'll be the integral that you need to plug into your calculator to get your answer. Let's look at another example. All right, for example 2, we're rotating region T around the line y equals -2. Our big radius is going to be the curve minus -2. And the little radius is going to be y equals 0 minus y equals -2. The little radius is always equal to 2. So we'll plug in a 2 for the little radius. The big radius is going to be our curve plus 2. So our curve is defined over here. We're going to take this curve, we're going to add 2 to it, and that will be our big radius. Our bounds are going to go from a all the way to 0. Now we do need to solve for the a. Now the way that you solve for a is you set your curve equal to 0. We would find 3 answers. We don't want those other 2. So you could evaluate it between -2 and -1. But basically we're just going to set our function equal to 0. And that's how you'll get your a. So here's our integral at the bottom. And you still got to solve for a. And you still got to plug in your big R and your little r. All right, here's number 3. We're going to take the green shaded region T. We're going to rotate it around y equals 1. The big radius is this distance here. So we need to do top minus the bottom. The top is 1, then we do minus, and the bottom is going to be 8x to the third. Then we got to do our little radius. The little radius is going to be top minus bottom, so the top is 1, then we do minus, and then the bottom is that sine function. Okay, our integral does go from 0 to 1/2. Don't forget to plug in your big R, then we do minus, then we plug in our little r, and that'll be it. Let's have a look at number 4. So number 4 is going to be a little bit different because it's going to be right minus left. The first 3 examples we did were top minus bottom. We are taking region T and we're rotating around the line x equals -1. So our big radius, if we do right minus left, it's going to give us 3y, and we do minus, and then the left is -1. Okay, our little r, we got to do right minus left. The right is going to be y squared, then we do minus, and then the left is going to be -1. So whenever you do minus -1, that's the same thing as +1. So let's fix both of those. We'll write +1. And then the bounds are going to be y values. So it's going to be y equals 0 all the way to y equals 3. So we're going to go from 0 to 3. And that's pretty much it. You just got to plug in the big R and plug in the little r. And then we'll be done. Let's have a look at number 5. Okay, for number 5, we're going to rotate region T around the line y equals 8. The big R, again, we got to do top minus bottom. So it's going to be 8 minus the curve. And then the little radius, it's going to be top minus bottom. So it's going to be 8 minus 6. But 8 minus 6 is just 2. So I'm just going to put 2 for the little radius. We are going from x equals 0 to x equals 2. So our bounds are going to go from 0 to 2. And then we're pretty much done. This is an easy one. Don't forget to plug in the big R. And don't forget to plug in the little r. Let's have a look at number 6. Number 6, we're going to rotate region T around the line y equals 7. Here's our big radius. We got to do top minus bottom. The top is 7. And we do minus. And the bottom is 2 root x. Okay, for the little radius, it's just going to be 7 minus 6. So the little radius is always going to equal 1. We are going from x equals 0 to x equals 9. So our bounds are going to go from 0 to 9. So again, this is another quick, easy one. Don't forget to plug in the big R. And don't forget to plug in a 1 for the little r. Let's have a look at number 7. Okay, here's another right minus left example. We're going to rotate region T around the line x equals -10. We're going to look here at our big radius. It's going to be the line 10 minus y, then minus, and then -10. Same thing for the little radius. We got to do right minus left. So the right is y squared minus 2. Then we do minus, and the left is -10. Remember, minus a negative is the same thing as a plus, so we can make both of these a plus. And then we can combine these two. We can also combine these two. So the big radius is going to be 20 minus y. Let's fix that. And the little radius is going to be y squared plus 8. Now the bounds are going to be y values. So let's have a look. It looks like it goes from y equals -4 to y equals +3. So let's write that down. And that's pretty much it. Other than, of course, we have to plug in the big R. And we have to also plug in that little r. All right, let's have a look at our last question, number 8. For number 8, we're going to rotate region T around the line y equals 2. Here's our big radius. We got to do top minus bottom, so it's going to be 2 minus, and then x over 2. Here's our little radius. It's going to be top minus, and then square root of x. We are going to go from 0 to 4, and that's pretty much it. Don't forget to plug in your big R, and don't forget to plug in your little r. But that's pretty much it. So most of the examples will be something like this. Now all we need to do is practice these.